Hello, I'm Adam from FTC Team 14892 Venom out of Alliance Academy in Cumming, Georgia, and today I'm going to be presenting to you all about gear ratios. It's a common question we get from a lot of rookie teams. So there are three main types of gear ratios. There's speed, torque, and direct. And we're going to be going over all three and their different uses. So just an overview about gear ratios. Gear ratios allow for a mechanism or drivetrain to have a torque or speed ratio or also a direct, and we'll get on to each type later. But we're going to go over the formula now. So for the step one in the formula, you're going to want to count the amount of teeth on your gear to use. And the formula is going to be the driving gear teeth divided by the driven gear teeth. So your driven gear is going to be your output gear. This is going to be the one connected to your mechanism or wheel, not connected to your motor. It's going to be the last gear in your system. And then your driving gear is going to be your input gear. It's going to be the first gear in your system. So it's going to be the one connected to your motor, most likely. Now, there is also something called an idler gear. An idler gear is a gear that's in between your driven and driving gear. So it does not play any role inside of it. It just is there as a placeholder. Your driven gear teeth inside of this example is going to be 12, and your driving gear teeth is going to be 60. So going back to the formula of driving gear divided by driven gear, 60 divided by 12 is going to be 5, which is a speed gear ratio. So let's now get into what a speed gear ratio is. So a speed gear ratio is going to have the output speed is faster than the input speed. Your wheel is going to be spinning faster than your motor inside of if you have a speed gear ratio. The mechanism/object will move faster than connected directly to the motor, and it's best for light robots, drivetrains, intakes, and flywheels, and in some instances, shooters. It can't lift heavy objects, but things will move faster with the speed gear ratio. So if you have a light robot and you want to move fast, a speed gear ratio is a good idea for your drivetrain. But if you have a heavy robot, a speed gear ratio might not be able to move your robot. A smaller gear connected to the output gear, or connected to the output, and a larger gear connected to the input is what makes up a speed gear ratio. And the ratio is going to be greater than 1 when you use that inside that formula. Think back to the example where the ratio was 5. Next up, we got a torque gear ratio, where the output speed is slower than the input speed, and the mechanism/object will move slower than connected directly to the motor. It's best for heavy robot drivetrains, lifting mechanisms like a 4-bar, conveyors, and catapults. It can lift heavier objects but will move slower. The larger gear is connected to the output, and the smaller gear is connected to the input. And the ratio is going to be less than 1. The ratio would be like 1/5, 1/2, 3/4, 5/8, something of that type. Next up, we got a direct drive ratio. A direct drive ratio has a 1-to-1 gear ratio. The output speed is the same as the input speed. It may have no gear ratio at all, and the mechanism is linked to the same shaft as the motor. That's also considered a direct drive. Now, the direct drive is best for drivetrains or intakes. The gear ratio is going to be equal to 1, and the amount of torque is equal to the amount of speed. So just as a review, the 3 different gear ratios are right here, and then you got the input gear versus the output gear, and then also what the ratio looks like, and then what each gear ratio is best used for. Now the formula is going to be down here again. It's going to be the driven gear divided by the driving gear. The driven gear is going to be the output gear, and the driving gear is going to be the input gear. If y'all like this video, please subscribe to our channel, and there's more videos yet to come. We've been releasing one weekly, and we hope to be able to help y'all with some of these videos. Good luck this season.